I'm Anil Kumar, sharing with you some questions from my viewers. Thanks a lot for watching my videos, placing excellent remarks and posting beautiful questions. That gives me an opportunity to address what exactly you need. I also noticed that you don't really subscribe to my videos. Maybe I post too many videos, right? So that must be disturbing. Anyway, here is a video which will help you recall the concepts learned while doing rational functions. From your list of questions, I've taken 6 which are presented here. We'll try to solve them one by one. And I've added one question in this list. I'd like you to pause the video, copy these questions, try them out, and then go through my solutions. So I think you can see 6 questions. The 6th one is the one which I really added. You will notice that most of these questions deal with horizontal and vertical asymptotes. However, in question number 6, you will be looking into oblique asymptote, right? And whole. So that makes it special. Also try to sketch this particular function. Question number 7 here is you have to write equation from the given graph, and once you do that, then you have to calculate what ABC is and provide their sum. Now these questions have been taken from objective type questions. I didn't have space to type out all the options, so I thought we'll discuss the concept that will help you to answer any objective type question on rational functions. So this video is good for all the students who are taking up functions, advanced functions, pre-calculus, you can say, even calculus, and admission to universities. Thanks for watching my videos, and I hope you enjoy the following solutions. Question number 1. Find range of the function f of x equals to x plus 1 over x minus 2. As you know, rational functions are of the type of polynomial function divided by another polynomial function. They do have discontinuities. Denominator equals to 0 leads to vertical asymptotes or sometimes wholes. In this case, the vertical asymptote is at x equals to 2, right? And the horizontal asymptote, if the degrees are same, can be calculated very easily by comparing or writing the ratio of their leading coefficients. In this case, 1 over 1. So we get 1 here. You can find x and y intercepts for the function by placing x equals to 0. What we get here is 1 over minus 2. Minus half is the value of y-intercept. So that could be kind of here. And the numerator is 0 for minus 1. So that gives you an idea that the graph will be kind of like this, right? So quickly, I'm reviewing the concepts and then explaining you. The function is always decreasing in its given domain, right? So all that. Now let's write down the answer. Range clearly is that we have a horizontal asymptote at x equals to 1. And this time the graph is not crossing the horizontal asymptote. It might in some case. Remember that, right? So anyway, to answer the question, the range here is given as y belongs to real numbers such that y is not equal to the horizontal asymptote, which is 1. Correct? So I hope that helps you to recall some of the concepts, right? So vertical asymptote also I'll write as x equals to 2. This is horizontal asymptote y equals to 1. That is the x-intercept at minus 1. And this is the y-intercept at minus half. Correct? Now from here, let's continue and quickly answer other questions. Question number 2. Determine asymptotes of this function. So you can see that denominator is 0 for x equals to 3. That leads to vertical asymptote. So we have a vertical asymptote here. And the equation of vertical asymptote is x equals to 3. That gives you the denominator 0. It is not a part of the domain of this function. Now, we also have another asymptote here, which is horizontal asymptote. Horizontal asymptotes you find by placing x value as very large positive or very large negative. In either case, you'll find that the first term approaches 0 and therefore the function f of x approaches 2. So in this case, we have a horizontal asymptote which is y equals to 2, right? So we have two asymptotes, horizontal asymptote as well as the vertical asymptote. You can always sketch this function. You can see that this denominator is always positive. Okay, let's move on. Question number 3. A very good question here. You are given f of x equals to 2a minus 1 times x plus 1 divided by ax minus 6. And it has a vertical asymptote at x equals to 2. So let's write down. Vertical asymptote is at x equals to 2. Find the horizontal asymptote of this function. That means you have to find the ratio of these two leading coefficients. Is that okay? So let's first find the value of a. When I say that x equals to 2 is a vertical asymptote, that means that ax minus 6 is equal to 0 for x equals to 2, right? So if I substitute here 2, then I get a times 2 minus 6 equals to 0. 2a equals to 6, a equals to 6 over 2, which is 3. So if a is 3, then what is the function? Well, in that case, the function will be, let's rewrite. We get 2 times 3 minus 1 times x plus 1 in the numerator divided by a is 3. So let me write down this as 3x minus 6. So that gives you 6 minus 1, which is 5. So I've got 5x plus 1 in the numerator, 3x minus 6 in the denominator, right? So the ratio is 5 over 3. So that is your horizontal asymptote. So horizontal asymptote here is the value y equals to 5 over 3. This ratio, right? So how do we find it? Simple. When x is very large, correct? If x is very large, then let me rewrite this to show you how to figure this out. So what you can do here is that you can factor out x, right? If you factor out x, you get 5 plus 1 over x. And in the denominator, if you factor out x, you get 3 minus 6 over x. Now, x and x cancel. So if x is large, then these terms approach 0, right? So these terms approach 0. And you're left with 5 over 3. Do you see that? That is how you find horizontal asymptote, right? So this concept was actually clear to you. I'm not getting into the details, but I can provide you with some links which will help you understand it. Let's move on. Question number 4, it is, if y equals to 3 is a horizontal asymptote of the given function, then find x-intercept of the graph. Now let's look at the function. F of x equals to ax plus 3 divided by 1 minus 2x. Now you notice that the degree of both numerator and denominator is same. Correct? It is equal to 1 in this case, and therefore we do have a horizontal asymptote, right? So we have a horizontal asymptote. What is the equation? The equation of horizontal asymptote will be y equals to a over minus 2, right? A over minus 2. So when the degrees are same, then the leading coefficients give you the answer. Perfect. So it has been rearranged. So it sometimes becomes difficult to figure it out. You can always write this as ax plus 3 over minus 2x plus 1, and then this ratio, which is a over minus 2, gives you the horizontal asymptote, right? But what we are given here? We are given that y equals to 3 is the horizontal asymptote. So this is equal to 3, correct? So if it is equal to 3, you can find the value of a as 3 times minus 2, which is minus 6. Now a is minus 6 for you. So let me rewrite this function. F of x equals to minus 6x plus 3 divided by minus 2x plus 1. Perfect. What do we need to find? Then find X-Intercept. So what do you understand by X-Intercept? When we say X-Intercept, that means what? That means y equals to 0, right? So y equals to 0 means f of x equals to 0. That means the numerator should be 0, right? That means this should be 0. So that means 6x, which is minus, plus 3 equals to 0. And we can solve this. So what we get here is 6x equals to 3, or we get x equals to 3 over 6, which is half, right? And therefore, the x-intercept for this graph is half. So that is how you get your answer, right? So our answer is x-intercept is half. Perfect. So that is how you are going to get your answer. So I hope it is clear. With this color, I've linked few related concepts. Let's move on to question number 5. Time is precious here, so I'm going a bit faster, but anyway, I'll provide some links to get into details. Question 5. Write equation of a rational function with vertical asymptote x equals to 4. So we are given vertical asymptote as x equals to 4, horizontal asymptote as y equals to minus 1, x-intercept, so we have x-intercept at 3, 0, right, and a whole, that means a common factor at x equals to 0, right? Okay, so what we can do here, looking into all these circumstances, we can start with the whole itself. So whole means a common factor. So this whole really means a common factor in numerator and denominator. Then only you get a whole, right? Okay, so that gives you an idea that my function y equals to will have x in the numerator and also x in the denominator. That ensures the whole. Is it okay? Now vertical asymptote at 4 means I have a factor which is x minus 4. So this x minus 4 leads to the vertical asymptote, right? Now we want x-intercept at 3. That means the numerator, after getting these x's cancelled, what remains here is x minus 4 in the denominator. In the numerator, if I substitute x equals to 0, in that case I should get, if I substitute x equals to 3, I should get 0 in the numerator. That's what it means, right? So basically, it is something like this, that because x-intercept is 3, that means y will be 0 at this point. Is it okay? So if I write x minus 3, that will ensure that for a value of 3, it is 0. Do you see that? Now, so that gives you a kind of idea of how we could really relate it, right? So that is how it is. Now, how do you get horizontal asymptote of minus 1? That should be the result of these two ratios. Is it okay? So So what we can do here is we can associate this with, let us say, negative. We could write negative here, right? X, 3 minus x, 3 minus x, correct? So 3 minus x could give you the result. We could change this sign to this. Do you see that? Now it satisfies all our conditions. So if I cancel x, I get a whole. Perfect. If I substitute 4 here, I get the vertical asymptote. And if I substitute x equals to 0, if I substitute x equals to 0, what do I get? I get y equals to, if I substitute x equals to 3, I get y equals to 0, and that becomes my x-intercept. Do you agree with me, right? So there we go. So that becomes your function. So let me write down the function as equal to. So instead of writing like this, I could also take it common outside. Is that okay? Or I could write like this. I could write x 3 minus x. Does it make sense to you? All up to you. You could write it in many different ways, correct? So that becomes your final answer, which is going to give you vertical asymptote at x equals to 4, horizontal asymptote at y equals to -1, and x-intercept as 3, 0. Right? You could even open this up and write it as, let's say, 3x minus x squared divided by x squared minus 4x. Right? So in different ways you could write this. So I hope that makes sense. So let's move on, and here is my question, which I added into your series. Question number 6. Write equation of asymptotes and name the type of discontinuities for the function y equals to x times x plus 1 times x plus 2 divided by x squared minus 1. Pause the video, copy the question, try it out, and then look into my suggestions. Question number 6. Write equation of asymptotes and name the type of discontinuities for the function y equals to x times x plus 1 times x plus 2 divided by x squared minus 1. Now I'll get into details of this function and also sketch it roughly. What we note here is that what is the degree of numerator? We see that the degree of numerator is 3, right? X cube, so it is 3, and degree of denominator is x square means 2, right? Since the degree of numerator is higher by 1, do you see that? It's higher by 1, we expect oblique asymptote. So there is no horizontal asymptote. There is no horizontal asymptote. You get horizontal asymptotes when the degree is either same of both numerator and denominator, or the degree of denominator is higher. Okay. Now let's rewrite this function. So we have y equals to x times x plus 1 times x plus 2. I could factor the denominator as x plus 1 times x minus 1 and then cancel the common term, which is this. So that means one thing, that we have a whole at x equals to -1. You see, the common factor got cancelled. So now we could write this equation as y equals to, I'm multiplying x, let me write first as this itself, and we have x minus 1. Now it's always a good idea, whenever you cancel, you write restrictions also. So let me write x is not equal to plus minus 1, right? So whenever you're working with rational functions, try to give restrictions, especially when you cancel some factors. Otherwise, they are not equivalent. Now we need to find oblique asymptote. How do we find it? Well, let's divide the numerator and denominator and let's find the oblique asymptote, right? So we'll actually, we could write this also as y equals to, let me open the bracket, x squared plus 2x divided by x minus 1, where x is not equal to plus minus 1, correct? So let's divide. So I'm going to divide the term x squared plus 2x by x minus 1 to find the equation of our oblique asymptote. We could divide by x, so we get x squared minus x, that gives us 3x. We can add 0 here, right? So bring down 0. So that gives you should multiply by 3 now, so we get 3x minus 3, so remainder is 3. So we do have an oblique asymptote here. So as I was saying, we have oblique asymptote which is y equals to x plus 3, right? So that is one of the asymptotes, and we already know discontinuity here. We have another discontinuity, which is a vertical asymptote at x equals to plus 1, right? So, and we have a whole at x equals to minus 1. So these become two discontinuities, right? So that becomes the solution of the question asked. Now if you get into details of this particular function, then you could actually sketch it also. So it's a very important question to sketch. So what you see here is vertical asymptote at plus 1. So let's say this is my vertical asymptote at plus 1. And oblique asymptote is x plus 3. So let's say that is the oblique asymptote, x plus 3. So the slope is 1 and the y-intercept is 3, correct? So that is how it is. Since we have an x-intercept, x is here, so we have x-intercept, there is a hole here, right? So what you have to be careful about is that when you substitute minus 1 here, what do you get? So if I substitute minus 1, so if I substitute x equals to minus 1 here, I get 1 minus 2 over minus 2. Do you see that? So what I get here is minus 1 over minus 2, which is half. So at half, I have a whole, correct? So at x equals to minus 1, somewhere here there is a hole. So I'm showing this hole with this circle here. Now that's a very small position. So the graph will be kind of like this. That's the oblique asymptote, and that's the hole, right? So it crosses, however, comes down like this. Do you see that? So that is how the graph will look like, and that is what we mean that this is an oblique asymptote, which is y equals to x plus 3. And clearly these x-intercepts are at, so we can say x-intercepts are at x equals to 0 and at x equals to minus 2. They are not the discontinuities. The function is actually, this point is minus 2. That of course is 0, right? And this vertical asymptote here is at x equals to 1, and the oblique asymptote equation I've already given to you, right? So that is how you could actually sketch the function. Some of you can get into details to find the minimum, the local minimum for this particular function. So I hope that helps, that introduces you to the concept of oblique asymptote as well as whole. Now let's move on to the last question of this series on rational functions review, question number 7. Write the value of a plus b plus c for the function f of x equals to ax plus c over 1 minus bx, whose graph is given to you. Okay, so basically from the graph you have to find parameters a, b, and c. So let's begin by finding the equation for the vertical asymptote, which is at x equals to 1. That means 1 minus bx is equals to 0 for x equals to 1, right? So I'll substitute 1 here. So 1 minus b times 1 equals to 0. So that gives us b as equal to 1, right? So we get the value of b, bringing them together. Now horizontal asymptote here is also in fact minus 1. So y equals to minus 1, that is minus 1, is the horizontal asymptote. Now from this equation, what we can do is, now let's analyze the horizontal asymptote, which is y equals to minus 1. That means the ratio should be minus 1. So this means that a over minus b is equals to minus 1. So a equals to minus 1 times minus b. Since b is 1 for us, we could write this as minus 1 times b is minus 1. So I'm writing minus 1. That gives me value of a as positive 1. So we get a equals to positive 1. So we have already found a and b. To find c, we need to look at the intercept. So we could look at x and y intercepts to find the value of c. Now numerator is 0. That means we are trying to find for what value of x will f of x is 0, right? So that means we can look for x-intercept. So let's look into the x-intercept now. So x-intercepts mean when is f of x equals to 0. That means ax plus c equals to 0, or c is equals to minus ax. Now we know the x-intercept is at minus 3, right? So x is equals to minus 3. We know at this point x equals to minus 3. I'm substituting this here. We get minus a value is 1, right? And x value is minus 3. And that gives us a positive 3 as the value of c. So now we know what c is. We can first write down our function, which is kind of like this. A is 1, so it is x. C is 3, so plus 3 divided by 1 minus x. That is your function, right? So what is a plus b plus c equals to? Let's rewrite. A plus b plus c is equal to what? We have to figure this out. A we found as 1 plus b is equal to, where did I write b? B is 1 again, and c is plus 3, right? C is plus 3, so it is 5, right? So let me highlight these. So a is 1 for us, correct. B is also 1 for us, perfect. And c is 3 for us. Okay, so that gives us the concept and also the answer that their sum is indeed 5. So we get the answer as 5. So that is the right answer. So I hope with this you learn about rational functions, what they are, what kind of discontinuities can they have, what kind of domain and range they can have. We didn't talk about increasing, decreasing intervals, but most of the time you can see from the graph, in this particular graph, it is always increasing. That is a characteristic for most of the rational functions of this kind, right? So ax plus b over cx plus d types, right? We also saw the functions where we had oblique asymptotes. So in those types of functions, we had intervals for increasing and decreasing separately, and we could have local maximum and local minimum also. We do have wholes when we have a common denominator in numerator and denominator. Horizontal asymptotes are there only if the degree of numerator is either lower than the degree of denominator or same. We have oblique asymptote if degree of numerator is 1 more than that of denominator, and we don't have any vertical asymptote if the denominator is not equal to 0, right? So those are few critical things which can help you. So feel free to write your comments, share your views, participate actively as you've been doing. Thanks for watching and all the best.